Welcome to online lecture series in organic chemistry, and we are discussing the chapter electronic spectra of the complexes. In earlier video we have seen the types of electronic transitions. Now in this video we are going to discuss the selection rules for electronic transitions. The electronic transitions are governed by set of selection rules, and the electronic transitions may be allowed or forbidden. The allowed transitions occur when molar extension coefficient value ranges from 10⁻³ to 10⁵. That is, allowed transitions are having high intensity. While the forbidden transitions, these forbidden transitions occur with much lower intensity. And for forbidden transition, the molar extension coefficient values ranges from 1 to 100, especially for symmetry forbidden transitions, and for spin forbidden transitions this molar extension coefficient value is 1 to 10⁻⁻³. So this is about the allowed transitions and forbidden transitions. Some transitions are allowed, some transitions are forbidden, and allowed transitions have high intensity and forbidden transitions have very weak intensity. Now first selection rule is Laborate orbital selection rule. This Laborate orbital selection rule, it is for complexes with the center of symmetry. The transitions which involve change in azimuthal quantum number, that is delta L, it is equal to plus minus 1, are Laborate allowed. So Laborate allowed, for Laborate allowed transitions, delta L, that is change in azimuthal quantum number value, it is equal to plus 1 or minus 1. And the transitions with delta L is equal to 0, these are Laborate forbidden transitions. Now another important thing is the transitions with the Girard to un-Girard or un-Girard to Girard orbital, these are Laborate allowed, whereas transitions involving Girard to Girard or un-Girard to un-Girard, these are forbidden. So this is about the Laborate orbital selection rule. Now the spin selection rule, second rule, it is the spin selection rule. According to spin selection rule, any transition with delta S is equal to 0, it is allowed, whereas transition with delta S not equal to 0, it is forbidden. Where this S, it is the resultant spin quantum number. Meaning of this is only those electronic transitions which do not involve a change in number of unpaired electrons are allowed. That is, when delta S is equal to 0, then it is allowed. And hence the transitions which involve change in resultant quantum number, that is delta S, these are forbidden. We'll take example. Suppose there is a electronic configuration S2 and P0. S orbital, it is having lower energy, P orbital is having little bit higher energy, and there are two electrons in S orbital. So electronic configuration is S2. Now suppose from this S orbital one electron is excited to P orbital, and before that, for this S2 configuration, the resultant spin quantum number, it is equal to, so for this first electron, that is this spinning with clockwise direction, this spin quantum number, it is plus half, and for second electron spin quantum number is minus half, and the resultant spin quantum number, that is S, it is plus half minus half, that is equal to 0. So for this S2, the S is equal to 0. Now suppose this one of the electron, it is excited to P, then resulting configuration will be S1 P1, and for this S1 P1 configuration, the resultant spin quantum number, it will be plus half, that is equal to 1, because for this electron the spin quantum number is plus half, For this spin quantum number is also plus half, because both the electrons are spinning in clockwise direction. So now S is equal to 1. So there is a, you can see here, there is a change in number of unpaired electrons, point number 1. Secondly, the resultant spin quantum number value changes. So delta S is not equal to 0, because the delta S it will be 1 minus 0, that is 1. It is not equal to 0, and therefore this transition is forbidden, spin forbidden. Suppose, consider another mode of excitation. Suppose electron excited from s orbital to p orbital, but the excited electron spinning in anti-clockwise direction. In that case, the resultant spin value, it will be plus half minus half, because for the second electron spin quantum number value will be minus half. So plus half minus half, that will be equal to 0, and therefore the delta S it will be 0, and this transition it is spin allowed, because as I said, any electronic transition with the delta S is equal to 0, it is spin allowed. So this is the spin allowed. Now consider another example. The hexaco manganese 2 ion, it is light pink colored. Now this light pink color of hexaco manganese 2, it is due to the spin forbidden transitions. Here in this complex, the manganese ion Mn2 plus has an electronic configuration D2, D5, and d orbitals split into two levels, T2g and Eg, and here the electrons are in T2g level there are 3 electrons, in Eg level there are 3 electrons, number of unpaired electrons are 5, and suppose one of the electron from T2g level it is excited to Eg level, then this is spin forbidden transition. So from here one electron excited and it is accommodated in Eg level. Now you can see for before excitation, the spin quantum number, resultant spin, it is plus 5 by 2. Number of unpaired electrons are 5, so 5 by 2, and after excitation the resultant spin quantum number, it is plus 3 by 2. Number of unpaired electrons are 3, so 3 upon 2. So there is a change in resultant quantum number, resultant spin quantum number, and therefore delta S is not equal to 0. This is spin forbidden transition, and remember the light pink color of hexaco manganese 2 ion, it is due to spin forbidden transition. So this is the second selection rule. Now the third important selection rule is the simultaneous excitation of 2 or more electron is forbidden. Meaning of this is, suppose at a time, suppose there is excitation of 2 electrons from T2g level to Eg level, that is highly forbidden, or it is spin forbidden. So simultaneous excitation of 2 or more electron, it is forbidden. So this is the next selection rule, and these are the selection rules